Hi, today we are going to learn transformation of absolute value function. So first, what you need to do all the time the same is outside and inside. So for the absolute value function, this is a absolute value function right here. Then inside absolute value, we call it inside. And anything outside here or outside here, that we call outside. So outside is y. Y is vertical, right? So y is vertical. And then inside is x. And then x is horizontal, right? X is horizontal. So you need to keep that and horizontal. And then outside y, you don't change. So it's keep the same. And x, that's inside, you change. So you copy that down. Then we're gonna use that soon. Okay? So first, let's find any number in front of it which is multiplying. So in front of x, I see 1/2 right there. And then also in front of absolute value size, I see -3. So that's a time. So those time, we're going to do it here. The first, outside. So this 3 is outside of the absolute value, right? That's outside. And then that's the absolute value times 3, right? Times 3 right there. Actually, this -3. So minus we separate out. So -3 is -1 times 3. So this -1 I separate out. That's also outside. -1. Okay? And then I see inside, which is x in front of it. That's all inside, right? And then inside, which is I see times 1/2 right there. So let's apply this. Outside is y, which is vertical, right? Vertical, outside vertical. And vertical times, in the inside, same thing. This times is stretch or shrink. And then vertical, same. Same means times 3. Then we call it by factor of 3. So by 3. And it's horizontal. Horizontal is because inside is horizontal. Horizontal is it's a change of the time, then we flip it, reciprocal. So 1/2 reciprocal is 2/1, so which is 2, right? And then when this is by something, this is bigger than 1 times 2, 3 times, that means stretch, 3 times bigger, right? That's a stretch. And smaller than 1 is shrink, but this is also bigger than 1 right here, then that's horizontal stretch. So this means vertical stretch by 3. This means horizontal stretch by 2. And then outside -1, outside is y. So this times negative number it's a reflection. Then but outside is y become -y. Y become -y means here. So like a y was here, but become -y is flipped it down here, right? So that's x reflection. So here x value from positive negative, then that's y-x reflection. But this is y become -y, which means x-axis reflection, right? So that's a stretch or shrink here, and then reflection right there, and then 3. Anything now left over, which is plus, -2, +2 like that. But first thing you need to do, we call it that's vertex, become vertex. So 1/2 x -2. Let's solve this equation, make it equal 0, and then solve equation. So make that one 0, x value, that's a vertex x value. So you do first, add to both sides, right? So like that. And 1/2 x equals 2. So to get the 1/2 right there, you multiply 2/1, which become 1, right? So I multiply 2/1. Multiply reciprocal. So become 2/2, which is 1. 1x, which is x, equals 4. So vertex x value 4. And y value is easy. Y value is all the time just following right here outside 1. That's y value 4,2. So this vertex is 4,2, which means this is x value. From 0, you move where? 2 to the right. 2 to the right, that becomes +4 right here, right? So that means 4 right and 2. Y value plus means up, so 2 up. So that's a transformation, this function from the parent function right there, okay? And then with that, we're gonna draw the graph. You know, the graph all the time, vertex is the key. So vertex we find it already, 4,2, right? And then draw the table. So let's draw the table. When you draw the table, so this is x, y. We need the x and y all the time. 4,2 vertex, put it in the middle. And then for the absolute function, and we put the 5 and 6, 1 bigger, 2 bigger, and 1 smaller, 3 and 2. We pop 5 points, then we can draw accurate absolute function. So let's find 5, x value 5, then you plug in x5 here, so minus 3 here, so 1/2, this is times 5, minus 2 and plus 2 right there, right? So I plug in 5 for the x, now you find this calculate, that is y value, right? So this is a 5 over 1, 5 over 2, minus 2. 2 is 2 over 1, which is times 2 times 2, makes same denominator, 4 over 2, with that, 5 minus 4, which is 1 over 2. 1 over 2 absolute value, that's same, just at 1 over 2. And so times negative 3, that's negative 3 over 2, which is 2 again, this is 4 over 2, right? So 1/2, which is 0.5 here. And then when this is x equals 6, this is 6 right now, right? And then 6 over 2, which is 3, and 3 minus 2, that's 1. So minus 3, absolute value 1, and plus 2, this is 1. And with that, minus 3 plus 2, that's negative 1. It's negative 1. All the time, absolute function is symmetric around the vertex. So this should be negative 0.5. This one should be matching the minus 1. So when you draw the graph, with that 5 point, you can draw the graph. 1, 2, 3, 4 right here. 1, 2. So 4,2 right there. As you see, 4 to the right, 2 up, right? And then 0,5, 0,5 probably here. And then 6, negative 1 probably here, right? And then same thing on the right side, 3.5, and then 2, negative 1 here. So if you connect like that, right? So this is a 4. So domain is for the absolute function all the time. Domain is x positive x value. Keep on going. So all real number. Domain is all real number. And then range is possible y value. Y value is here 2, and everything is smaller than equal to 2, right? Smaller than 2, right? Here, so then y in range is y value. So y equals more than equal to 2.